Hey, welcome back to week 6 of Intro to GIS. This is Yash Yadavalli. In this week, we'll be learning about spatial data processing or geoprocessing as it's commonly called. Mostly we'll be talking about attribute extraction, where you actually extract features using spatial queries or attribute queries. You'll also learn to aggregate polygons to larger polygons and appending layer, merging layers, and all that good stuff. This sort of work is called geoprocessing because this is processing of geographic features. So you in a project, typically you would have to sort of like combine multiple processes together to actually obtain a desired product. So essentially we'll be learning about this geoprocessing, and we'll learn how to build and share your document workflows by creating macros using ArcGIS model builder, and we'll get a taste of that too. So moving on, let's focus on attribute extraction. So it is exactly how it sounds, extracting attributes based on extracting features based on an attribute query. So we have already done some of this before. What we do is, let's assume we have a state of Illinois, but we only want data for only one county, which is Cook County or some other county. So what we need to do is figure out what field represents counties. If there is a name field, we can just say name is equal to Cook County, or perhaps there is an FIPS code, and the Cook County FIPS code is 031. So we use that to actually select the attributes, select by attributes, and then we go ahead and say county is equal to 031, and then it's gonna get selected. So what we can do is we can just export that selection to a new feature class or a shapefile, by just right clicking and data export data, and make sure you have the selected features while you are exporting this data. We have already done this, and then add to the map as a new layer, right? So feature location extraction, nothing but spatial query. So before we jump to that, I want to actually go ahead and work on show you like the walkthrough on how to do this. If you would like to turn to your chapter 8 in the book, tutorial 1 book, and then just work with me on tutorial 8.1, that would be great. So I opened my tutorial 8.1 map document, which is in the maps folder under ESRA Press GIST1. So in this exercise, what we are asked to do is to actually extract features based on an attribute query. So here we have City of New York, and we have 5 boroughs or counties as we know it: Manhattan, Bronx, Queens, Brooklyn, and Staten Island. So what we need to do is so we need to extract Manhattan area or Manhattan borough, so that we can create like a steady area for Manhattan. So this is how we go about doing that. Click on selection, click on select by attributes. So now I know New York boroughs is the polygon layer in which there is the boundaries defined. So I'm just gonna go to name, double click on name, and then I'm gonna get all the unique values. So I know Manhattan is the one I want, so I'm gonna double click on Manhattan, click on verify. So I'm gonna click on apply. So now that I have selected the Manhattan county or borough based on an attribute query, I want to export it as a new feature class. So I'm going to right click on New York boroughs, click on data, export data, and then I'm going to select my location under chapter 8, and I'm going to save this as a file geodatabase feature class. And now I can see my 2 geodatabases that were already in my chapter 8 folder. I'm going to double click New York because I want this to export within the New York GDB. and I'm gonna type this as I'm gonna give it a name, Manhattan, and I'm gonna click on save. Click OK and add the data to the map. So I created a file, or a polygon file, polygon shape feature class called Manhattan, and I added it to the map. So the next step, so that's how you extract features. So if you can't see roads, essentially if you have your roads underneath Manhattan, you can't really see it. So anyways, you can give it any color you want, or if you want to keep it the same way you want, like the way it is, it's fine with me. And then let's use select features tool to actually do the same same thing again, using a different tool, not by select by attributes window, but using a select tool. So I'm going to clear the existing selection, and now what I'm going to do is go to my select list by selection tab in my table of contents, and then I'm gonna select make my New York boroughs the only selectable layer. So I'm gonna right click on this and say make this the only selectable layer. Once I did that, I'm gonna click on select features, and I'm gonna select Brooklyn. So once I have that, I'm gonna go back to my layer, right click on it, click on data, click on export data. I'm gonna export this as Brooklyn, and click save. So we got, I'm sorry, I exported Manhattan again, that was my bad. So I'm gonna right click on New York boroughs, click on data, export data, and I'm gonna select Brooklyn again. I'm gonna overwrite Brooklyn, click OK. I'm gonna add it to the map. So we have created Manhattan and Brooklyn. So the same way you can actually repeat the same steps for the other boroughs, the other three boroughs, which is I don't know what this one is, Staten Island. And we can create one for Queens. And then we can create one for Bronx too. If you want, you can go to select by attributes and get unique values and click Bronx. Double click Bronx, click on verify, OK, and then create your selection that way. So anyways, that's how you create your feature classes based on a selection. So picking up where we left off on the presentation, let's look at feature location extraction, selecting by location. So this is the most unique feature of GIS. Is even if you don't know what the attributes are, what the fields are, and all that stuff, what they mean, you don't need to really know about the data behind the features. You can just use the spatial relationships to identify features. So you can find features that are within another layer. For example, let's have we have Cook County census tracts, but we want only the city of Chicago census tracts. So all we have is a boundary of Chicago. We don't really have any field within the tracts attribute table that says, okay, these tracts belong to city of Chicago. So we can't really use attributes, select by attributes, or you know, what we need to do is we can use the municipality layer, and then city of Chicago is a municipality, so we can essentially use that to select the select the census tracts within that particular city. So what we need to do for select by location is select Chicago from the municipalities layer, essentially. So we have a municipalities layer, we select that, and then we we go to select by location, and then select features from Cook County census tracts, and then what we do is we select these options. We select select the target layer, which is Cook County tracts, and then and the source layer would be Cook County municipalities. So before you do this, we need to make sure you actually export this Chicago as a shapefile by itself. It would be much easier that way. And then you select the spatial selection method, where the target layer features have their centroid, which means the center the centroid of each of the census tracts must be completely within the Cook County municipality. So once we do that, we select all the census tracts which have their centroid within the municipality, and then you can export them as Chicago census tracts. So quite easy to do it. Again, this is just purely spatial selection. We didn't have like an attribute that will allow us to do this. So other location based selections or location or proximity selection, for example, health officials want to know the polluting companies near water features. So what we do is we select the points which are within a certain distance from these rivers or lakes and rivers. So again, go to selection, click on select by location, and you'll get select features from. So essentially we select the polluting companies, and then the source layer will be the lakes and rivers layer, and then we'll select target layers that are within a distance of the source layer feature. So 0.5 miles, we want to identify all the polluting companies which are about a 0.5 mile distance from the water body. So we do that and we get a selection, and then we can export that layer or maybe do further analysis on that. And points near points, so sometimes we need to know like polluting companies from schools or something like that, or we want to know grocery stores which are close to an address. In any case, this is a point to point selection, point near point selection. So again, we do a spatial selection or select by location, where we select features from schools that are close to the source layer, which is the polluting companies, within a distance of 1 mile. So we select all the schools, and now we can we can get the schools together, and we can actually take our research further after this step. So what's other selection? Polygons intersecting lines. So sometimes we need to know what jurisdictions or cities or counties that are affected by a construction project on a major highway, so that you can send them notices or work with them. There could be different applications to the same same methodology, same process. Again, we go by select by location, we select the neighborhoods, we select major streets, and then you selected features, so that you don't have to create a new feature class. Before I said you have to create a feature class. You really don't need to do that. It's better if you do that, but you can essentially say use selected. So that's the benefit of using use selected features. Instead of actually creating a new feature class, you can just use this option right here. And then you have to select the spatial selection method. Here now we're gonna use the option target layers features intersect the source layer feature, because we want to actually alert all the neighborhoods which have this construction project running through, or the highway running through them. So we have to select that option, and then based on that we can get that's the selection, and then we can essentially get like an Excel sheet of all the selected neighborhoods, maybe talk to their respected authorities based on that. So another example of lines intersection polygons is that so let's say, for example, this is a public works office, and somebody wants to know what streets and sidewalks will be affected by potential floods, so that they can alert the business owners and so on and so forth. What roads to close. There could be multiple applications from this map. So what you need to do is again go to selection, select by location, and then from that you'll select sidewalks as a target layer and FEMA flood layer as the source layer, and then you'll say target features intersect, the same option as before, and then you'll apply like a you can apply a buffer distance if you want to be absolutely safe, or you don't need to do that. It's up to you. It's up to what you come up as a policy for that. And then you as you can see, what roads will be affected. Roads and sidewalks will be affected based on if there was a flood. So you can use that information to come up with alternative plans and routes and stuff. Similarly, there is polygons completely within polygons. So sometimes you have to identify all the buildings which are within a particular zoning area. Somebody wants to know the square footages, or how much revenue we can generate out of these buildings. Maybe they want to create a CID or a TIF or something like that. So anyways, again we use the spatial selection method, from which we'll select the buildings that intersect with, that are completely within the source feature layer, which happens to be the zoning district A. So based on that, as you can see the difference here, even though this feature seems to be within our district, these features are not selected because a part of them is outside the source layer, so it won't be selected. So that's the spatial selection method we chose, is that the target layer features are completely within the source layer feature. So that's not the case here, so these buildings will be excluded. Let's talk about geoprocessing tools. So we already have some knowledge of what geoprocessing is. Essentially it is GIS operations to manipulate data. Typically takes input data sets, manipulate and produce output data sets. It's sort of like, okay, this is a methodology, you input the data, something comes out, and often you use multiple data sets to actually accomplish a certain goal. So some of the common tools that we'll learn in this exercise are extract and clip, and there are overlay methods like intersection and union, and there are some data management tools like dissolve, and some other tools like append and merge. We'll see what they are and how they will be used. So accessing tools is a critical part of actually running the tools, because you need to find them first. Some of the most common geoprocessing tools are available from the geoprocessing menu. We'll see where they are, and then they are available from the ARC toolbox. You can also search for them by accessing the tools via the search window. We'll see how that's done. So let's go back to the map document and take a look at how to access these tools. So I'm in my map document. What I want to show you is how to access these common geoprocessing tools. So if you click on the geoprocessing menu item, so you have a bunch of tools right here. Most of the ones that we are going to learn about are right here: buffer, clip, intersect, union, merge, dissolve. So these are the most common tools, and there is a results window which will help you like look at the current results. Yeah, any geoprocessing results will be displayed here. We'll see how that works a little later. And then there is model builder, which we'll come back to, and then you can essentially click on search for tools right here. So if you click on search for tools, it's going to open up the search window, and then the focus right now is on the tools portion of it. You can search for data, you can search for maps, you can search for everything, but here we want to look for tools. So let's say merge. So it's sort of like an intelligent search. While you're typing, it's going to give you some options. So merge, when you can click on that, and it's going to bring up the tool. So the same way you can access the same tools using our toolbox. Our toolbox, there are analysis tools where there is extract, clip, select, split table, table select, and then there is arrays, identify, intersect, spatial join, union, update, and so on. And there is buffer and point distance. These tools you might end up using a lot, perhaps. It depends on what you're doing. So add X and Y coordinates, which could be pretty useful when you're trying to generate centroids. Delete features could be useful. So these are like categorized by the type, or like put under the category that they belong to. So we'll come back to this. Although there are only few tools here, there are about 1500 tools overall in the toolbox that are available for us. Some of them are not really shown right here because they are hidden. You can search for them if you know what you're looking for. You can essentially search for those tools and bring them up. So if I want to clip something, you can just, if you don't know where clip tool is, you can just search for clip tool. So so that's how you access the tools you need for geoprocessing. So let's continue our presentation. Let's talk about some of these features before we actually go back and work on them. So clip is nothing but just as the word says, it does clip the features based on a feature you will select. It just consider this as a cookie cutter tool. Okay, if you have roads and you need to clip them based on a central business district, you can essentially say clip streets, and the source layer will be your CBD boundary, and the output features will have the roads of just the CBDs. And then there is you can access clip under extract. Once you open that, you'll have input features, which is our streets. Clip features will be your outline, and then output feature you have to save it as like a different file, CBD streets or clipped streets or whatever. You can have like a tolerance if you want to do that, but it's usually left alone. So clip versus, what is the difference between clip versus select by location? Now it's an important difference, because clip has clean edges. It absolutely clips all the features based on the boundary. So when you select features that intersect this boundary, you might get some dangling lines because the street might extend beyond a certain district or a neighborhood, or in this case a CBD. So you have to decide what you are trying to do here, so that you can come up with the right tool that you need to use. So let's go back and work on clip. So let's try this select feature on Manhattan roads. So what I want to do is create a shapefile for the roads in Manhattan. So the first thing I want to do is select by location and see how the result, examine the result and see if I like it. I'm going to select from New York Metro roads that intersect with Manhattan. Click on apply. As you can see, there are like these roads extend well beyond Manhattan boundary because they still intersect with the roads with the Manhattan boundary, although they are outside technically. So I'm gonna export this data as Manhattan. So let's clear the selection and see how that's looking like. That's if I'm creating a map for Manhattan, that's not a pretty good feature layer I want to use. So I'm gonna remove that. I'm gonna use my clip tool, which is available to me under extract under the arc toolbox. So I'm gonna go to New York Metro roads. See, if you have this help window on, like turned on, it's gonna tell you what it is that you're doing, what these individual boxes mean. So it's always useful to have that on all the time. I'm gonna use Manhattan as my clip features, and then I'm gonna export this into Manhattan roads and call them. Actually, I'm gonna replace the feature I just created. I'm going to replace that. Click OK. It's gonna say you can't do that because it's already there. So I'm gonna say Manhattan roads 2 and see the result this time. Oh, that looks a lot better, don't you think? The roads are nicely trimmed by the boundary, although even the bridge is trimmed, so you really don't want that. So it sort of it takes some manual work to actually clean that up a little more, but you can use this clip feature to actually trim your features or snap them exactly to the boundary that you choose. So that's how you use clip, and that's the difference between clip and select by location. Now let's run the same analysis for Bronx. We need roads for Bronx too. So this is what I was talking about, results. When you go click on results or access results from right there, you're gonna get something like this, in which you have used one geoprocessing tool, and it is called clip. So you can essentially go back and see what you have done. The input feature class was Manhattan roads 2, and the inputs were Metro roads, and you can essentially look at all the stuff that was generated, and you can sort of like look at the messages. If it was failed, it would say failed because of so and so error, so that you can fix it. So it's pretty useful to know where these results are stored. So I'm gonna go back to my arc toolbox, double click on clip. I'm gonna select Manhattan roads 2. Clip features will be Bronx. Oh, looks like I did not create a Bronx feature class, which I'm gonna do right now probably. So I'm gonna click here, select Bronx, data, export data as, oh actually I did create that. I'm gonna go back to our toolbox and click on clip again. Input features will be Manhattan roads 2, Manhattan New York Metro roads, and then I'm gonna select Bronx, and then I'm gonna export this as Bronx roads, and then click OK. So I got roads for Bronx and Manhattan, which is what 8.2 is about. So let's go back to the presentation. So dissolve tool, what it does is it combines adjacent polygons to create new larger polygons. So let's say we have city data in which we have parcels, but we need to create a block a layer from the parcels, what we do is, if we have a block number within for each parcel, we essentially dissolve this layer based on the block number, and then we can get the block outlines. While doing this, again, it needs a common field to remove interior lines within each polygon to create these new polygons, and it also aggregates data while dissolving it. So so in this example, what we are trying to do is create a regional map for United States. So we have states layer, and then we have sub-region field, in which we have east, north, central, east, south, central, middle Atlantic, mountain, New England, Pacific, and so on and so forth. So we need to dissolve these by this field so that we can get the desired result. So under data management, under generalization, you have dissolve. You double click on that, you get the window. You select input features as United States, and the dissolve field is sub-region. And then if you want to aggregate some fields, like let's say you want population to be calculated for all the regions, so you can do that, and then click OK. Essentially you get this kind of a result where you have the Pacific, mountain, west, and the south, west, north, and west, south, east, north, and so on and so forth. So that's the use of dissolve. Let's see how that can be used. That feature can be used within ArcMap. So I'm going to go back to my ArcMap. I'll open tutorial 8.3 it is. I'm going to save my work. So once I have 8.3, so you'll see a map like this. I'm going to zoom in maybe, and then you can save it as if you want, you can make a copy of the same map. But let's look at the New York zip code layer, which we are going to dissolve to create postal zip code, postal areas, postal office areas, I guess. So the PO name has is the field we need to actually dissolve. So it looks like it has New York or the zone that it belongs to. So we're going to dissolve that field. What I'm going to do is go to Arc Toolbox, click on I'm going to look for dissolve. I'm going to go to my search toolbar and click on dissolve. Actually, we don't need this for the coverage, so just gonna click on dissolve. Click on data management tool, and then I'm gonna input my New York Metro zips and dissolve by PO name, and then we're gonna aggregate population of 2003 for these. The statistic type, I want a sum of a population of all these zip codes within each New York post office boundaries, so to speak. So I'm gonna click on OK, and let's look at the result here. So as you can see, the result has been created. Let's open the attribute. Let's open the attribute table and see what that looks like. So essentially, we had a 181 zip codes before. Now we have them by post office name, and we have 46 post offices, so to speak. So we can create like a outline for this, maybe something in like a dotted line or something, so that you can see the zip codes underneath at the same time. So save your work and let's move on to the next geoprocessing tool. So merge tool, what it does is it combines multiple input datasets of the same data type into a single new output dataset. Typically, when you use this tool, both the datasets you are trying to merge should have the same table structure. It's not an absolute necessity, but it is highly recommended. So in this example, we're going to look at how an Illinois campaign manager needs a single voting district um, from these 3 different counties. They have their own voting districts, but he wants to combine all of those and create one master voting district layer. So again, you go to data management tools, there is merged under general, and then you double click on it and you essentially input data sets. You select all 3 and you specify the output location and a name, and then you have a resultant layer where you actually have all the voting districts combined into one. So a pretty simple tool. Let's see how that works. Let's open 8.4. So here what we have is the water layer for each one of the counties. So we need to create a unified water layer by preserving the same table structure so that we can use this for further analysis. So this is how you use it. You search for it, or you go to our toolbox under data management. Under general, you have something called merge. So as you can see here, there is an example of the tool where you combine the west half to the east half of United States to create a United States. So very similar to what we are trying to do. We're going to select all the layers, and then we're going to merge. So we're going to save this as New York water and then click OK, and we'll have one a combined file for water of all the counties. So we can turn everything off, we can give this like a blue, and voila, we have all the features we need combined into one feature class. So let's learn a little bit about intersect. So intersect is nothing but it computes a geometric intersection of input features. So if you input the features, so when you run this, the output feature class will be just the intersection of your input layers. So inputs could have different geometry. You can say you can intersect lines with polygons, polygons with lines, polygons and polygons, and so on and so forth. So in this example, we're gonna intersect buildings with flood zones and see what the buildings, so that you can provide this information to each of the building managers or something like that. We want the flood data to be attached to each of these intersecting buildings. So we are joining polygons to polygons. So we're gonna find this tool under analysis, overlay, intersect, double click open, and you're gonna join these 2 features, which is buildings and FEMA flood, and you'll select a location for your output, and then the output type could be critical. Sometimes when they have different geometry types, if you are joining intersecting lines and polygons, you can specify whether the output has to be a line or a polygon, stuff like that. And then you'll join them. So once you intersect them, what happens is the buildings which intersect the flood zones will be created as a new layer, and they will have the flood zone information, which is the FEMA flood ID, perimeter, FEMA flood information, the floodway, and all that. So that could be critical information for some of these buildings. So let's see how that's done using ArcMap. I'm gonna go back to my ArcMap. I'm gonna open 8.6. Oh, actually, I'm sorry. Oh yeah, I'm sorry, it's 8.5. So let's open map document 8.5. I'm gonna click on changes. I'm not gonna save that. And now that we have this, what I want to figure out is what are the roads that intersect with this flood zone. So I'm gonna click on I'm gonna open attribute tables of both layers. So it has highway names, it has road names and the type of roads and alternative names and stuff, and it has the New York water information. So essentially what we are trying to figure out is what are the roads that are on top of the water, so that this emergency official can sort of like prepare for this by knowing the name of the water boundary that each road crosses over. So let's get to work. I'm gonna go to our toolbox, and then under overlay there is intersect. Double click on intersect. I'm gonna select both my features. New York. You can drag and drop these layers, by the way, instead of actually selecting from the drop down menu here, or you can add stuff from outside the table of contents by opening or accessing through a browser window. Anyways, we're gonna save this as roads water intersection, and then the output type will be line, and then I'm gonna click on OK, and now the resultant so I can maybe call them out as red. So you see all the red features are the ones which are on top of water bodies. So now the emergency official can now prepare his report, or maybe come up with strategies on how to keep these roads open, or so on and so forth. So all these roads now have the water body that they actually cross on top of. So that's how intersect layer works. Let's go back to the presentation and look at the last tool, which is union. So union is overlaying two polygon layers, and resultant layer will have a combined attributes of both the input and both the input layers. So contains all the polygons from both the input layers, whether or not they overlap. So what happens is, in this example we have neighborhoods and zip codes. So when we create a union of these neighborhoods and zip codes, the resultant layer, again you access this under overlay, under extract to, under analysis tools, and then you double click, select those two layers, save the layer in a specified location, and then the resultant layer it's actually describes the zip code, and it also has, so since the union layer will have we'll see what the results look like, but the union would be a better description of characteristics than just like central business district 15222, the zip codes versus zip codes sort of a thing. So what we can do now is we can go back and look at the two tables. So this is the attributes of the zip code, where you have state, block number, and population square mile. And here what you have is, in the neighborhoods, just the
neighborhood name and acreage. So it would be useful to have the population and some of this demographic information as part of your neighborhood, so that you can get a better sense of what these neighborhoods are like. So what we do as part of the result, before we had this CBD, and there are two zip codes, as you can see here. You see these two? These are two different zip codes. Once we had like a union, the new polygons with combined data will have the post box name, zip code name, and then it will also have the neighborhood name. At the same time, it has populations and so on and so forth. So this is pretty useful information. If somebody is looking at just the neighborhood data, it might be less useful since it doesn't have any demographic data. So let's see how this can work. So I'm going to go back to my book and access my 8.6, and here I'm going to, so let's take a look at some of these neighborhoods, the data we have at hand. I'm going to change the color just, or maybe increase the line weight of zip codes. So I want to identify the zip codes. So this is a zip code, that zip code right there, it has a PO box number and so on. It has some population statistics, population of 2003, but let's look at the tracks underneath. What information they have. They have the state FIPS, county FIPS, they have race, they have age, they have household information, housing information. This is extremely useful stuff that could be joined with the zip code, so that we have both the tables under one. At the same time, we have zip code information for the other layer too. So let's employ this union tool, which is under overlay, under analysis. So I'm going to select both my zip code and tracks layers, and I'm going to save this as zip tracks union, zip tracks union, save that, and then you can click on join all attributes, and then I'm gonna click gaps allowed, which means if there is a gap between those two layers, it will be allowed. You can uncheck that if you'd like. So I'm gonna uncheck that and click on OK. So let's take a look at the resultant layer. As you can see, so it has it joined. Let's look at this. It joined the zip code, it joined the tracks, and then it joined, oh, actually we are looking at the tracks, so let's look at the union layer. So it has the zip code information and the population of 2003 combined with the rest of the stuff. But as you can see, even though these are let's look at the zip code information, examine that a little bit. So the population of 2003 is 33,088 for all these individual features, but that's not true. They have a portion, they only have a portion of that 33,000 within these track boundaries, so that's not exactly divided between them. We'll learn about how to do that a little later, maybe in chapter 9. But right now what you need to identify or realize is that your features are smaller. Let's turn all this stuff off. So your features are smaller, and it will have the geographies of both, the outlines of both zip codes and tracks, and they have the data of both layers. So that's actually union geoprocessing tool. Let's talk about Model Builder before we actually go ahead and work on Model Builder. Model Builder is nothing but it's an automation tool that can create custom programs that document and automate geoprocessing workflows. So when you are working on a project, so workflows could be complicated. So somebody is going to ask you, how did you do that? How did you create, what are the steps that you follow to actually get to that specific data set? Sometimes it's hard to explain what you have done, especially after like 15 different steps. So it's a good way to actually document the process at the same time while you are automating this for future repetition. So it essentially automates and strings functions together using this model builder interface. For example, let's say you have census tracts for a county and you want to create neighborhoods for a city. So what you do, many steps are needed, like joining, dissolving, and removing joins, and so on and so forth. So it's important to document and actually automate this process so that you can repeat these steps in maybe different cities. So the first step is to actually open the map, and as you can see, you have municipalities for outside the city boundary, which is the city in question here is Pittsburgh. So we need to create neighborhoods for Pittsburgh. So we want to create something like this. So usually neighborhood names are not included with census tracts. So what happens is we have a crosswalk table which was created by the user to actually it essentially lists the neighborhood name and the tracts that are included in each of these neighborhoods. So as you can see, Bloomfield has 5 different census tracts that combine to form Bloomfield. So what we're going to do is first we need to set the geoprocessing options, which we'll see how to do that, and then we'll create a new toolbox, and essentially we're creating our own tools for running this analysis, and then we'll create a new model and we'll add some tools to the model, and then we will automate we'll look at what this means. Blue means parameters, green means outputs, yellow is actually the tool itself. So we'll see how to actually perform this or create this model builder using ArcMap. So let's get started with assignment, actually exercise 8.7. So open 8.7 map document, which I already did, and I'm going to browse to my table of list by drawing order view, and you can save it as a different map document if you want. And then on the main menu, I'm going to click on geoprocessing options and make sure I have the override the outputs of the geoprocessing operations turned on, because sometimes if you don't have it turned switched on, that option, it's gonna essentially have a bug in the program where it won't go through, the model won't go through. So click on OK, and then I'm going to create a new model. So I'm going to click on Windows, Catalog, and then I'm going to browse to my location, which is SRA Press, GST1, my exercises, chapter 8, in which I'm going to right click and say new toolbox. The toolbox, I'm going to call it chapter 8. Chapter 8. And then I'm going to open that, right click on that. Since that's an empty toolbox, I'm going to right click and say new model. So the model window opens. So what we need to do is, the first step is to actually join the crosswalk table to the layer to actually perform the dissolve. So I'm gonna go back to my Windows search and I'm gonna look for join, add join, look for that. under data management, I'm going to drag and drop that field, drop that tool into my model. So once I have that, what I'm going to do is double click on add join, and I'm gonna select tracks as my layer name, and the input join field obviously has to be FIPS, and then the join table would be PGH crosswalk, and we're gonna join the SDFID and FIPS at the same thing. So we're gonna join those two fields, and then I'm gonna keep all target features as optional. So I'm just gonna turn that off, and I'm gonna click, and then I'm gonna click apply and click OK. So as you can see right here, that our model has some inputs. These two becomes parameters or inputs, and the tracks become outputs. So when you don't have inputs or outputs, the add join thing is just like a hollow black thing, like we have seen before. So I'm gonna auto layout this thing. I'm gonna click on auto layout so that they look nice. So the PGH crosswalk is the input, is the table we are joining to the tracks, and then it is becoming tracks 2. So I'm gonna open this. Okay, I'm gonna close this again, and I'm gonna click on save model button, and then I'm gonna run the partial model. So I'm gonna right click and say click on run. So essentially this part of the model has run, and now it says, it gave me some notification. It says as executing add join. It has kept SDFID and FIPS as the common field, and it joined based on those two fields, and it elapsed in almost less than a second. So I'm gonna click on close, and then let's take a look at tracks. Open attribute table for tracks. I'm gonna scroll down and see that the hood has been joined, the neighborhood name has been joined based on the SDFID to the tracks. So we need to dissolve these tracks to actually form the neighborhood boundaries. So the next step is to actually search for the dissolve tool. I'm gonna search for dissolve, and then drag and drop dissolve under data management to the model that we are building, and I'm gonna use the connect tool right here. I'm gonna use the tracks as the input field for my dissolve. So I'm gonna use the connect. I'm gonna drag and drop it onto dissolve and select input features. So that became my input features, and you see the model has sort of like verified everything, looks good, but the thing is we need to add some more variables. So I'm going to click on open on dissolve, right click and click on open, and we need to save this into dissolved polygons GDB. We're going to save this as neighborhoods and click on save. So dissolve field is optional, but we know that we need to select the PGH crosswalk neighborhood name as the dissolve field. So after you have done that, so I'm gonna add some statistics to this. One is I'm gonna add stats to population of 2000. That is sum, and then I'm gonna add stats for there are some racial information, ethnic composition, so to speak, some, and if you want to add more you can do that. So essentially I'm giving some statistics like demographic information to the neighborhoods also. And then what I'm going to do is multi-race. Okay, maybe if you want to do Hispanics at the same time and click on some, that's fine with me. And then you're gonna click on OK. So now we have, as you can notice here, the output name has changed from tracts to join or something like that to neighborhoods, because we have given a name to that. So I'm going to right click and say add to display, because if you run this model and if you don't have add to display, it won't be added to the display automatically. So now I'm going to right click and say, right click on dissolve and say run. As you can notice, once the model is run, there is like a shadow underneath. So all the ones that have a shadow underneath them are the ones that the model has already finished running. So I'm going to save this model again, and then so this model has run, and see that my neighborhoods has been created. If I open the attribute table of the neighborhoods, I have sum of tracts, population 2000, sum of white, black, and Hispanic. I have some race information, and I have the neighborhood boundaries created. So essentially I can change the outline to perhaps red, and then I have my neighborhoods. So that's how you use model builder. If somebody asks you what did you do, how did you create this, essentially you can show them what you have done. So that's the methodology that you have followed. So now moving on to the next. So if I want to repeat the same steps again, that's not going to work, because the add join already exists. So we need to remove the join so that I can rerun this model from the beginning. So I'm going to go back to my search toolbar. So let's see. Let's click on run. So it says all the processes have already been run. So let's go back to search toolbar, and I'm going to say remove join, and from the data management I'm going to remove join, and from the joined polygons, which is the tracks, to layer name or table view. And now I'm going to right click and click on open join. So you can either select the table you want to remove, or you can just remove everything. So I'm just going to remove everything. So now I'm going to right click and remove the join that we have done before. So I'm going to close that. So now I'm going to make sure that the join has been removed. So what's the advantage of actually removing the join is, the next time I run add join, it's going to run again, because I can run this entire model at once now for the second time. But before, if you did that, it's gonna stop at adding join, because a join already exists. So what we need to do right now is save our model. If you want, you can do the auto layout thing, and then we can essentially run the model again. So we can click on, I'm gonna click on model and say validate entire model, which means it is resetting the data we have just created, essentially like undoing all the steps we have just done. So I'm gonna click on run. So now you see we have automated this process, so it's gonna run and create our neighborhoods successfully. So click on close, and now open the attribute table. As you can see, our neighborhoods has been created again. So essentially, so let's remove the neighborhoods and let's rerun this model. validate entire model. I'm going to click on run again. So it's going to go through all the steps that we have done before and creates neighborhoods. So, and it's been added to the map. So you can change the color essentially, and that's your neighborhood boundaries. That's how you use a model builder. So now for actually repeating the same steps, maybe perhaps in different cities or for different areas, what you can do is this could be a general tool. It doesn't need to be specific to Pittsburgh. So what we are going to do is generalize this model. So we need to label them accordingly. So what we need to do is rename some of these steps. So tracks has to be base map polygons, and then PGH crosswalk has to be, I can rename these crosswalk essentially. That's the crosswalk table, and then the tracks 2 will be joined polygons, and neighborhoods will be output dissolved polygons. Rename output. And then this will be base map polygons 2. So make sure your model looks something similar. If you want, you can rearrange this model. You can say you can have your dissolve here and your remove join here, and then you can have your output. You can lay this out any way you want. It doesn't need to be auto laid out. So if your model looks something like this, it will be just fine. So I'm gonna save this model, and the next step is to actually add model parameters, because this data is predefined. So if I open this, it is actually using the PGH crosswalk. What if we want to do this for the New York crosswalk and I want to use the tracks for New York? This model doesn't really allow me to input those particular feature classes. So in order for me to do that, you need to create model parameters. So I'm gonna right click on base map polygons and say this is model parameter, which means the next time, actually let me show you what that means. So if I save this model, close this, the next time I go to my catalog and I double click on this model, this tool doesn't really allow you to select any of the stuff that we need to actually run this model, which means it is hard coded. So we need to sort of like allow this model to choose some of the parameters. So how we do that is by creating the model parameters. I'm going to right click and say edit. So the base map polygons will be model parameter, and crosswalk will be a model parameter too, and then dissolved output will be a model parameter as well. So we need to add some variables to the model. So what if the names of the fields have changed in a different city? What if the field name was not STFID, it is STFID2 or something like that? So we need to create, for the add join, we need to make sure that the user has an option to actually change the choose the input join field. So I'm gonna right click on add join and say from parameter input join field, so that I'm gonna fit everything, auto layout, fit everything. Okay, anyways, it could be laid out any way we want. So I'm gonna right click and make two variables output join field. So what that's doing is it's essentially, if you double click on it, it's gonna ask you to input the join field here. That's great because but you can't see that in the model tool when you double click on it unless you add it as a model parameter. So we're gonna add them as a model parameter as well. So the next step is to, so now that we have done this, let's save the model, close this, and see the results of our work so far. Double click on the model, and now you can select the base map polygons, and you can select the location where you want to save this stuff, and it's going to ask you for the input join field, output join field. Essentially this is pretty awesome because we can essentially do these steps for any city we want, any place we want. So that's the advantage of creating this model using this model builder, is that it is documenting the process and it is letting you automate your future repetitive steps. So I'm going to click on cancel here. I'm going to go back to my catalog, edit, model. So I'm going to right click here and say create label, and the label is going to be model to dissolve a subset of base map polygons. So this is essentially notes for the future users. If you are working on this, essentially you can they can read your notes and they can probably understand what you try to do. So it's always a good thing. And then you can add the sentence down there, which is, you must examine the base map polygons attributes and crosswalk table and note their field names and share the same polygon IDs names for the use of parameter values on the opening the model. Anyways, it's the same thing. We can save this, and then we can break this label into several lines and so on and so forth. It's all cosmetic from now on. So I would expect you to do that. Add the label. Essentially, if I want this on 2 different lines, I can right click, and display properties, and we can choose the number of pictures, center picture, just labels, and then we need to choose, we're gonna choose center for this. I'm gonna right click and I'm gonna double click on, maybe after A I want that subset of base map polygons at different line. I'm gonna press and hold shift and hit enter so that it becomes a second line. So anyways, you go ahead and do that and add model name and description for documentation by go to model properties, and the model name will be dissolve any subset of dissolve polygons. And the label would be dissolve any subset of polygons. For the description, you can type in anything you want, and then make sure you have stored relative paths, and then click on apply and OK. So that's how you create your model. And when you save your work and click on go to catalog and double click on dissolve any subset of polygons, it's going to ask you a bunch of inputs, and you can essentially do the same things. Again, click you can go to catalog, double click on this and click OK here, and it's going to execute the same model, and it's going to display the same neighborhoods again. So that's model builder, and good luck with your assignments. Thank you for watching.